Well, hello again, everyone. Mr. Reeves back with you today. And in this video, we are going to continue looking at rotations. And specifically in this video, we're going to look at rotations in increments of 90 degrees. Because as I mentioned before, 90-degree increments are the only ones that you're going to be asked to specifically find the coordinates for. All right, so let's go ahead and take a look. Well, let's go back to our handy dandy Inspire calculator here, and we can see what I showed you in the last video. We have this triangle in quadrant 1. I have added the coordinates of each of the vertices. So you can see the blue vertex is at 510, the red one is at 52, and the green one is at 2, 2. So one of the things we're going to be looking at today is not just how to rotate the objects, but also to look for a rule that we can apply to rotations, just as we did for reflections. When we were reflecting over certain lines, we found some rules. We can find some rules as well for rotations. All right, so again, we're going to start up here in the first quadrant. I'm going to click on my slider over here, and I have now rotated it 90 degrees clockwise, where if I had gone 270 degrees clockwise, counterclockwise, I would have gotten the same result. So again, just a quick reminder, when you rotate 90 degrees clockwise, you will move one quadrant. There we go to 180. 180 moves us 2 quadrants from where we started. This also would be 180 counterclockwise. Remember, with 180 degrees, clockwise and counterclockwise give you the same result. If I click it one more time, I've now gone 270 degrees clockwise, which, by the way, would be the same as going 90 degrees counterclockwise. All right, that moves me 3 quadrants. 270 moves me 3 quadrants. And of course, if I go 360, I've gone all the way around. I've moved 4 quadrants, and I start back where I was. So there is a rotation. That's 90 degrees counterclockwise. You could see it's also 270 clockwise. There's my 180 in both directions. There is my 270 counterclockwise, which would be 90 clockwise. And there I am, back to where I started, a rotation of 360 degrees counterclockwise, which of course is the same as going nowhere clockwise. All right, so let's go ahead then and let's see if we can do this using paper and pencil. So in your textbook on page 293, they have a triangle similar to what I was just showing you. And we're going to rotate that triangle. So I'm not going to be paying attention to any of the text over here. I'm just going to simply recreate what we just did. Now this triangle is not in the exact same location. In fact, we actually have a point on the vertex, which will be very nice, because as we rotate this circle around, I hope you can see that point A is not going to go anywhere. And again, they have an arrow indicating counterclockwise rotation. I like to start with clockwise, so I'm going to go ahead and go this way. All right, so I'm going to start now by making a circle that's going to go ahead and show us where those points should be. So I'm going to go here and I'm going to make a blue circle right here for point B. And as you can see, point B is going to travel along that circle. All right. Now I'm going to go ahead and make a circle for point C. And point C is going to travel along that circle. Now I don't need to make a circle for point A because point A isn't going anywhere, right? As I move that triangle around, hopefully you can see that point A will not be moving. All right, so we are going to, we're going to go in increments of, this is still on wide one, we don't need that, all right? In fact, let's go here, right? So we're going to be doing 90 degrees. Ooh, too thin, too thin. Sorry, guys, but got to have it a little bit wider. I don't do well with it quite that small. So we're going to be doing 90 degrees. Then we're going to be doing 180 degrees. and then we're going to be doing 270 degrees. And I'm going to be doing all of these in the clockwise direction. All right, which of course will have a counterclockwise. If we were to go counterclockwise, all right, going counterclockwise, 270 degrees would be the same as, let me move this over just ever so slightly so I'm not in my grid. All right, 270 degrees counterclockwise is the same as 90 degrees clockwise. 180 is the same for both. That's the great thing about 180. And 90 degrees counterclockwise, going this way, 90 degrees would be the same as going 270 that way. All right, so let's take a look and see. Remember, all right, one quadrant is 90 degrees, 2 quadrants is 180, 3 quadrants will be equal to rotating 270 degrees, or rotating 270 degrees is 3 quadrants. All right, so again, A is really easy. A is not going to go anywhere. In fact, I'm going to make A a red dot here, okay? It's not going to go anywhere. I'm going to go ahead and make B blue, and I'm going to make C green. All right, so C is going to travel on the green circle, B is going to travel on the blue circle, and A is not going to go anywhere. All right, so I'm going to start with B, because after A, B is the easiest. If I'm going to move this one quadrant 90 degrees, I hope you could see it's just going to travel right to there, right? So B is going to travel right to there, and A is going to be there. The only question is, where is C going to be? All right, and I'm going to go ahead and get out my protractor. All right, and as you could see, I can line this up, and there's my 90-degree angle. And I'm going to go ahead and rotate my protractor right there. And can you see that this red line is on C? And if I go 90 degrees, it's right there, okay? Right at that point right there. Can you see where that point is? All right, so I'm going to go ahead and put a point over here so I could see where it lines up with. But if we count right here, it's like 1, 2, 3, 4, right? And down 2. So over 4 and down 2. And we said that was green, right? So over 1, 2, 3, 4, and down 2. So it looks like my circle is slightly off because it really should be on the circle. All right, so now if I were to go ahead and draw in my triangle. All right, so I'm going to go ahead and remake this triangle in black here. Okay, so there is my pre-image. Remember we call that first one a pre-image, right? So now when I do the triangle, it's going to go like this. Okay. All right, so can you see here? And I'm going to go ahead and color this in. So I'm going to make my original one orange. So this is my pre-image. My pre-image right here is orange. And then I'm going to go ahead. Sure, I'll make this one pink. This is my first image after a rotation of 90 degrees. So there is my A, and this would be my A prime, right? So it's also A prime. I'm going to put a prime there. All right, this is my B prime, and right over here would be my C prime. So this is a rotation of 90 degrees, a rotation of 90 degrees, and we did that by following the points along the circle. All right, so now let's go ahead and take a look at these points that we have, though, and see if we could figure out what happened here. So we started off with 0, 0, 0, 0 did not change, right? So I'm going to write up here 0, 0 went to 0, 0. Didn't change, right? All right, what about B? B was 2, 0, right? B was at 2, 0, and now where is it? Now it's at 0, negative 2. Interesting. And C was at 2, 4, And now C is at what? Now C is at 2. I'm sorry, C prime. My apologies. Now it is at 4, negative 2. Interesting. 0, 0 didn't change. 2, 0 went to 0, negative 2. They switched around, and the second one is the opposite. And look at 2, 4. They switched around, and the second one is the opposite. All right, so we did this by drawing, but let's take a look at those rules. So if you're in your textbook, actually, all right, so I'm going to get rid of this protractor. Goodbye, protractor. All right, so I am in your textbook on page 301 if you wanted to turn there. It says algebraic representations of rotations. This is the one that we just did, 90 degrees clockwise. And if you have your book, it would be good for you to write in your book 270 degrees counterclockwise. And I'm going to put CW for clockwise because it's not going to fit, all right? So 90 degrees clockwise or 270 counterclockwise, this is how you can get it. Notice we started off XY, and when we were done, they switched the locations, and the second one was the opposite. All right, so they kind of describe it a little bit different way. They say to multiply the x coordinate by -1 and then switch them. For me, just the way I think, I don't know, maybe my brain's kind of funny. I just like to say switch the order around and then make the second one the opposite of what it was. Okay, but you can also follow their direction as well. So that will always work. That rule will always work. So if we go back to our handy dandy Inspire, right? If I look at this example that we have here, all right, so for example, the green point right here, the green point originally was at 2, 2, right? 2, 2. And now if you take a look, it switched. Well, they're the same, right? But I mean, you could think of it as switching, and then the second one is the opposite. What about the blue point? The blue point was originally at 2, 5, right? 2, 5, and now that blue point is at, whoops, excuse me. That's not correct. My sincerest apologies. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What was I thinking? What were you thinking, Mr. Reeves? The blue point was originally at 5, 10, right? And now it's at 10, -5. So they switched. And the second one became the opposite. Let's see if I can get this one right. The red one was originally at 1, 2, 3, 4, 5, 2. And now it's at what? 2, -5. They switched, and the second one became the opposite. All right, so if we want to look at a rotation, let's see here, if I can get back to that previous page that I was on. There we go. If we want to look at a rotation of 90 degrees clockwise or 270 counterclockwise, switch them and make the second one the opposite, right? Switch them and then make the second one the opposite, or you can use it the way that they've described it. Okay, so actually let's go back. Sorry for all this flipping through these pages here. All right, so this one was for 90 degrees here. Let me label this one up here. So this one was for 90 degrees, and again I'm going to use clockwise. All right, okay, so now let's do 180 degrees. Okay, 180 degrees. That's going to move us 2 quadrants, so we're going to be over here. All right, so again, that B is just going to travel along this circle. So if I go 90 degrees, I'm here. If I go 100 degrees, sorry, not 100 degrees, 180 degrees, I'm going to be right over here, right? 90, 180, half a circle. Again, point A is not going to change. So nice of point A to be on the center of rotation. Anytime you have a point on the center of rotation, it will not move. All right, so the hardest one is going to be point C. All right, but the great thing about a rotation of 180 degrees is it just goes straight across. So all I have to do, I don't have to get out my protractor, right? I just have to follow this straight across. That's 180 degrees. It's half of a circle. And again, I wish I had been a little bit more careful with that original circle because it really should be right here. It should be on that circle, right? But that right there is going to be my point C double prime. All right, so I'm going to make that line go away because I don't want this to be as cluttered. But we saw, right, going straight down, we're going to end up right here, right? Whoops. Woo. I just made it worse, didn't I? Right here. All right, and that's going to be, now we're going to call it double prime, right? This point right here is going to be my B double prime. And now I'm just going to put another one on here, right? This is just going to be a double prime. That point is not moving. It was A prime, now it's A double prime. All right, and then I'm going to go ahead and draw in, excuse me, my triangle from A double prime to B double prime to C double prime. How nifty is that? Isn't that cool? All right, so let's pick a pretty color here. How about we use this one right here, this bluish purple color? And let's color in this rotation. This represents a rotation of 180. And again, it could be 180 clockwise or 180 counterclockwise. They are the same. All right, so let's go ahead and record those. I'm going to do it down here. So 180 degrees. All right, clockwise, but again, it would be the same as counterclockwise. So if we take a look, we have 0, 0. And what did 0, 0 go to? Well, 0, 0 didn't change because it is on the center of rotation. So 0, 0 stayed at 0, 0. Oh, it's really, come on, I'm trying to do it a little bit neater here. 0, 0 stays at 0, 0. All right, what about B prime? B prime again started at 2, 0. And now it's at what? Now B prime is at negative 2, 0. All right, I got to tell you, the smaller I write, the harder it is to make it neat. So I'm going to try one. Uh-oh, my Moby here, the battery's getting low. It's starting to freak out on me. So let me try one more time. 2, 0. And it switched to what? Negative 2, 0. And finally, C double prime here was originally 1, 2. 1, 2, 3, 4, right? Same as our original one up there. 2, 4. And when we're done, where is it now? Now it is at negative 2, negative 4. All right, so if we take a look, 0, 0 stayed the same, but that's a special case. 2, 0 went to negative 2, 0, interesting. And 2, 4 went to negative 2, negative 4. So those are the opposites. Those are the opposites. And if I were to ask you what the opposite of 0 is, the opposite of 0 is 0. So let's go back to our textbook and see what our textbook has to say. It says 180, we're down here at the bottom, just multiply both coordinates by negative 1. They become the opposite. So this actually, 180 is just the easiest one. There's just nothing else to say about it. By the way, 180 degrees, it's going to be clockwise or counterclockwise. We're going to get the same result. And just a reminder that 90 degrees clockwise is not there anymore, but hopefully you wrote it in, is the same as 270 degrees counterclockwise, right? So we have the rule for 90 degrees clockwise and 270 degrees counterclockwise. Now we've got the rule for 180, the easiest of all. Just make them the opposite. Simply make them both the opposite, which you get by multiplying by -1. One last case to look at. 90 degrees counterclockwise, which will be the same as 270 degrees clockwise, of course. All right, so last one, and then we are done. All right, so let's go back to our handy dandy Inspire, shall we? So I'm going to go back up here. Okay, actually, there we go. So this is 270 degrees, right? This is 270 degrees clockwise, right? So let's just take a look at what we have here, and let's see if we can come up with the rule, and then we'll draw it. So we'll do this one kind of in the reverse order. We've been drawing it and then coming up with the rule. Well, let's see if we can come up with the rule and then use that to help us to draw it. So we have our red point. Our red point was what? 1, 2, 3, 4, 5, 2. And now our red point is what? -2, 5. Are you seeing it? All right, our blue point was originally, this is the one I messed up on before, right? Isn't it 5, 10? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5, 10. And what did 5, 10 become? -10, 5. All right, and finally we have our green point right here. Our green point was 2, 2. And what is it now? It is now -2, +2. So what's happening? Well, just like when we did the 90-degree rotation, they're switching, right? 5, 10, 10, 5, 5, 2, 2, 5, 2, 2, 2, 2. But notice the first one now is the opposite of what it was, all right? So we switch them and then make the first one the opposite. Instead, as with 90 degrees, we switched them and we made the second one the opposite, right? So if we go back to our textbook page right here, and I'm going to go back to where I just was, where I wrote this down. Okay, so the first one we did, right, was 90 degrees clockwise, where we switched them. X, Y became Y. We switched them, it became YX, and then we made the second one the opposite, right? Then we did 180, which simply, they stayed in the same order, right? XY was XY, but now they were opposites. Well, now with 270 clockwise, which of course is the same as 90 degrees counterclockwise, those give us the same result. Once again, we switch the order. XY goes to YX, but this time we make the first one the opposite, right? Or again, you can follow their instructions of multiplying by -1 first. I just like the whole switch and then make the opposite thing. All right, so if we go back now, okay, back in time, here we go, back to where I wanted to be. So again, this was 90 degrees clockwise, where we switched them and made the second one the opposite. This was 180 degrees clockwise, which is the same as 180 counterclockwise. We simply made them both the opposite. Now we're going to go one more time. We're going to go 270 around, or this would actually follow the arrows. So if we use the rule, so I'm going to do this one right here. So this is going to be 200, whoops, wrong color. We want black. Here we go. So this is going to be 270 degrees clockwise, right? So again, I'm putting these all with the clockwise, but we could do the same thing counterclockwise, lining it up right here. So our 0, 0 stays at 0, 0 again. The center of rotation never changes. So if a point is on the center of rotation, it's there. All right. What about point B? Point B was at 2, 0. And what did we say we're going to do? We're going to switch them. And we're going to make the first one the opposite, right? Well, what is the opposite of 0? The opposite of 0 is 0, so it's going to stay at 0. All right, and finally, our third point at C was 2, 4, right? 2, 4. And what did we say we're going to do? We're going to switch them and make it 4, 2, but we're going to make that first one the opposite, and it's going to be negative 4, 2, right? So if I plot those points right there, that hasn't changed. It was a prime, then it was a double prime. Now it's a triple prime, right? All right, point B, B double prime is going to be at 0, 2. So it's going to travel one more time. See how B just traveled along each of the axes? That's really cool. So the easiest is when it's the center of rotation. The next easiest is when a point is actually on the axis. So this is going to be our B triple prime. This is our third image, right? And then finally, we're going to have C triple prime, and C triple prime is at negative 1, 2, 3, 4, and 2. And hey, look, that one actually looks like it came out on the circle like it was supposed to. And that's our C triple prime. And if we go ahead and draw that triangle in, A to B to C. All right, and I don't know, let's go with yellow, I guess, here. We'll color that one in yellow. Gosh, that line is a little bit too low. Bummer. Alrighty, but you get the idea. Kind of looks like one of those windmills, huh? With one of the wings is a little funky. Okay, so the orange one was our pre-image. The pink one here was a 90-degree rotation clockwise, or we could have gotten the same thing by going 270 counterclockwise. This bluish purple one was 180 degrees either direction. And finally, this last yellow one was 270 degrees clockwise or 90 degrees counterclockwise. So again, guys, you are welcome to do these by doing the actual rotation like we did, or if you want to learn those textbook rules, all right, then you could just use these rules or these algebraic representations and you can get the same result. All right, so guys, I got to tell you, this is just something that comes with practice. It'll be slow when you start, but the more you do it, the faster you will get. And I surely hope this video helped you learn how to rotate polygons in increments of 90 degrees around the origin. Have a great day, everybody. Thanks for watching.